download them here, and I put them on my Teams. But anyway, 1, 2, and 3. Well, actually, I made a mistake because I just choose the best files. I hadn't marked most of those, but I can tell you that what we are going to have a discussion about what they've done. What do you need to do further? I usually don't believe that someone can get 100% for a report. What do you think? Does anyone able to actually write down a report and get a full mark for it? The answer is no, because there's not a math. The only thing that you deserve to get a full mark for it is going to be a mathematics. When you write down that all those are going to be correct, that you know how to do the procedure. So anyway, let's check for this one. I don't know if you know those guys or not, but they had quite neat report. They had student number has been shown. What we need to know further is going to be the group number. That will be very nice if you have to have the group number. And of course, put the full name. Don't expect that we're going to search the student number. So full name, student number, the part you worked on, the signature if you want, and you can write down something here like, what is the group number? This will be much easier for me to search for you when I get to give you the marks, because we usually give the individual marks for different people, depend on the feedback, or what you call it, the peer review. Like you didn't like what your colleague done, you write me something and I can actually tell if this one is better, if the party was done better than these two parts, I can give you a higher mark. Table of the context, where we can go directly to the problem that we have here. Okay, well, yes, I can accept that if it's going to be within the same equality of this scanning. That's for the hand calculation that we talked about earlier. As I told you once again, that they are very clear. That's very nice. Of course, you can have a better quality for the handwriting, but this is a good one. The thing is that you don't have to do the hand drawings for the free body diagram, because you can get the one available for you on the models or the PPT files. You can add something to it. If you would like to add more details like this one, you can simply just write it down or type it on the PowerPoint, and you take the snapshot for it. The known parameters, well, this should be typed. Well, do some effort. I know that they're doing the effort, but all this stuff already available in the code, so you can copy it and paste it as a text. The useful equation, the same thing, the equation are there. Okay, from the kinematic diagram, what you are going to have in the case of the slipping or non-slipping. Obviously, all these things has been given to you in the PowerPoint and in the code itself. So I prefer that. Well, I can tell that the efforts has been done for this one was good. It's handwritten, but it's going to be more neat if we're going to have it typed, especially when you're going to do most of the things to be copy and paste. So the condition and the assumption were given, and the solution has been given. So this will be about the manual solution here. Put the parameters and get the answers. I will accept that. You don't have to type the solution, as long as it's going to be a neat and good one like that. So he got the values. He has some discussion about that, and then he's going to compare it to the model. Now he put the parameters. You remember that we discussed about this one earlier, where you can find those. This is the one done by the MATLAB, the subtask number 2. It's going to be doing the things by using the analysis. Wait a second. Yeah. What did they miss here? They didn't scale it. They didn't scale it. So this is part of the works. You remember that the things like the logo, like the multiple arrows, to scale it to the size, this should be used. And also, you learn that if I would like to find the value at certain position, you only need to zoom in using the lens. And then you can compare it to your hand calculation. I don't think they did any, I don't think they made any comparison between their hand calculation and this calculation. So that's something actually you should do. Okay, I think that they did finish the whole work and start the problem number 2. Where is the non-slipping and where is the slipping one? Well, if I'm marking this one, if I'm going to consider that this part is going to be something like 25%, they will receive something like 12 out of 25. Okay, so you can see that these are not the only results we would like to have. What are the graphs? They've already been given to you 2 scenarios, slipping and non-slipping, where you can get actually something like these graphs for both scenarios. So why they don't do it? Also, it's going to be nice to take some of the snapshots for the model of the truck where the part is slipping on the top of it. The problem number 2 is about the volume, the one we just talked about it, with the questions already being given, and he defined every one of these parameters. Okay, looking at the pipe initial value. Yeah, this is going to be a good actually discussion about the things at the beginning or introduction. These are the results we got. That's correct. Again, they hadn't done the scaling. Okay, that's number 3. Okay. Okay. Yeah, well, that text compared to the other one wasn't that good. I think that the other person who did this work, he preferred to do it on his tab. It can get better quality than this one, right? Because I remember that in the tab, you can change the handwriting to a text, right? You can do that, right? There's an app, yeah. So why they didn't do that? Okay, so now the other test is going to be the cylinder 1. Well, it's going to be nice actually to show that that's the fixed hinge, that case 1. Then he jumped to task 4, task 3 attached to a brick. They didn't show the brick 1. Okay, and no simulation result for that. So what we need to do actually is we need to have a comparison between what's happening if it was a block, what's happening is going to be a cylinder, what will be the effects of the coefficient of friction. These are, I know it's more details, but this is a 40% report. So it's worth actually to have something like that. They got something like 8 out of 10 or maybe 9 out of 10 for this report, while it's missing many of the stuff. I'm going to be a marker for most of the report, not most of the report. Actually, I gave the marking to the other people, most of the marking, but I'll try to be more restrict, and I will tell them to be more restrict. It's 40 degrees. That's what, sorry, 40 degrees. I'm actually, I was thinking about thermodynamics. It's 40 marks. Yeah. So it's 40 marks. So if you would like to have a good portion of it, you should be good on it. Okay, so the problem number 3, I can tell you that this guy is doing better than the other guy. Sorry for that, but obviously he's spending some time doing the sketches. It's neat. Take the photos of it. It's look nice. Okay, so I hope he understands what he's doing. We can tell about that very soon. Oh yeah, well actually I'm putting that online. Okay, as a video. So I'm going to run through them very slowly so you can find the equation because they found it. Okay, so these are the parameters, and it seems that they have the equations has been done here, so you can make use of that. Okay, and we go further. This another set of the equation. Wait a second, I gave them that last year. I remember this equations. Yeah, I gave them that last week. Anyway, now you can pose it and get a use of these equations. Okay, and the value is going to be about finding the coefficient of friction to have the case of the tipping or not tipping. Now, that's the modeling. Once again, he just got the results from the MATLAB, but I don't think that, no, wait a second. So you should get it from the Simulink as well. That's not what the code is for. You remember the code was had 4 sections. Okay, it had 4 sections. 2 of them were simulation. The first one is only about the 4 degrees of freedom, and the last one was about the 6 degrees of freedom. So why he didn't cover both of them? Okay, so please do that. It's not about the hand calculation only. The model should be utilized as much as you can. Problem number 4, I expect that this will be the second person who was using the pad to do the work. Yes. Okay, well, that's good. And that's not good. Okay. So task number 2 involved looking at the direction of the cart. After each impulse, the Simulink simulation is established using the known variables from task number 1. Okay. And here they go, these results. We did that last week. They didn't bother themselves to trim the bottom here. Well, actually, I know that. When you talk about that, it sounds like the effort is the most important thing. Sometimes the knowledge is good, but you're not going to put the knowledge with good effort, and it's not going to give you a good result. But anyway, I can see that at this time, at least they covered most of the part has been generated using the model, and this will be actually a respectable thing. So they covered most of the things, including the one done by the MATLAB figures, and it should be okay. Okay, so you need to write down your impression about what you've done. Okay, the achievement of the projects, what worked, what didn't work, what will you change if you're given another opportunity. Well, actually, this question is going to be quite critical because you're still doing the things. You still have the opportunity from now till you submit the report. So I will take a look to another report. I don't know who's the marker. What those people missing is something very important. You remember that we're supposed to have a presentation. The best way to get the presentation is not uploading the link to the comments area in the what's the name? Sorry, Canvas. Yeah. So it's much better to add the link here. Upload the presentation to YouTube. Never upload an MP4 file. That's maybe is going to be something like 1 giga in size, and it's going to require me something like 2 hours waiting for it to download, and then it doesn't work. So just put the thing on YouTube and add the link to there, and something like what those people actually have done. So if I would like to watch the video, just click here, and here we are.
Hi, my name is Joanne Mateo. And I'm Katya. And we're in group
Okay,
16.
so that's a good example for the video they've done. They choose the first scenario.
So the first
Okay, for no slipping and for the slipping case. Okay, so that's what actually I expect to see. Okay, so 3 views. I think that 2 of them is me. Yeah, so yeah, that will be the best way. Make it to YouTube and put the link there. Many of the students do it the other way. They put it to the Google Drive, because I know that most of your generation using the Gmail. Just remember that in the Google Drive, you have an option to share it on YouTube. Just take that, that's it. And use YouTube. I don't want to go to Google Drive and then ask me for permission. Just take it, put it on YouTube. This will be the easiest way. And the other way, by the way, you can use the UTS account to log into YouTube. Have you tried that before? Okay. So the only disadvantage of that is when you graduate, your YouTube channel will disappear. and they don't give it to the LNA. And that's what's happening with this subject. No, the other subject. Actually, one of the lecturers, she put all the videos there. And when Terry took over the class when she left, he found that all the video doesn't work. So I told him that's very easy because she was using her YouTube channel using the UTS account. When she left, it's gone. So it's not her fault. She didn't know that. Okay, now once again, this is another example. I remember those girls. Actually, they were doing very well. So you can see that at the beginning, it's quite neat. What I'm missing is the group number again. I always prefer to have the group number. It's going to be much easier for me to go and search. Sometimes they're putting only student number. This will be a harder task for me to find. And also, I need to find the partner to put the mark individually. More details, table of content. So this is actually a very promising beginning. 61 pages. I can tell you they covered most of the stuff. Yeah, well, something like that can deserve anything between 32 to 37, because I said there's no 100%. That's for me. So you should cross finger that I'm not going to be the marker. Yeah, you can tell that they were done all the tasks from 1 to 4, which is something that we would like to see. They made the hand free body diagram, which is good. Okay, so this is the free body diagram, kinetic diagram. Nobody wants to make your life harder. So as I told you, you can use the one that's available for you. I showed you how to do it. I showed you actually the example on how to put the diagram on the Word document. Make a table cell, and this will fix it in position. So it's not going to be interference with the text. I think that you saw some of the files where the text is going to be here and then go down here. Okay, so the known parameters has been defined this as a table. That's very nice. The boundary conditions, the unknown parameters to be specified outputs has been tabulated as well. The S1 is going to be theories and principle has been given. They typed all the equation. Actually, as I told you, once again, you can copy that directly from the model, and you can once again put them in the cells. So it's not going to be movable. All the equation has been listed, conditional and the assumptions has been listed. The solution, that's the equation, that's the final equation out of that. It's been numbered. It's very nice. It's actually very, very nice things. They did the calculation and they put the results for all the equations here. And then they got the final solution without showing me the answer, which is, it's okay. They already have the parameters to be calculated. And now for the modeling, cut and paste from the screen, which is good. And then they show us results for the non-slipping has been assumed. Changing some of the parameters, do the basic calculations, run the things, get the answers, analysis based on the results. Otherwise, again, they don't have the Simulink results so far. And that's something that I don't want to see. I want to see the Simulink results. It's not only about the MATLAB. Okay, let's see what they're going to do next. So this will be a case of the slipping of properties. So I'm going to add the coefficient of friction here and repeat the process. Theories and the principle has been defined, tabulated. The answers has been tabulated as well. The MATLAB verification for this one, the result will become from here, and it's going to be shown against the manual calculations. Okay, now that's a Simulink model. They got, yeah, well, they're doing well. Yeah. So they put everything. That's actually a comprehensive report. We would like to have something similar to that. Okay, the analysis has been also done. Well, actually, that's perfect. Actually, if they didn't get a high mark, this would be too bad. But this is perfect. By the way, the video is going to be uploaded to you. It's going to be unlisted. The only reason for that is because it's about the integrity. I don't want to share someone else's work. without their permission. But because you are my students and you may know them, so don't tell them. And we're just watching that. We are not showing the physical file. We only have a look on it, which is something different. Now, they did the same thing for the suspended pipe. Okay, so they defined the problem. They went through the diagrams and they set the parameters, the equations. Okay, all good, all good. Sorry, I'm going too fast, but because the time is about to finish. The assumptions that we have, the solution steps as a tables. They put that on Excel sheet, obviously. Calculation processes. Okay, and the final equation that's going to be used in your model. That's the model. And then they're going to run the MATLAB code. That's the Simulink model that we have done, actually, including the description of it. Task number 2, which is the start. Task number 2, MATLAB defining the parameters values. So this member is going in a good way by making something like a manual. So people like you don't have to watch any videos. If you're going to read something like that, you'll know what are the steps by following the steps that she described for you here. She described all the steps. She told you what will be the next results, what are the parameters to be changed. Actually, it was much better than just putting the parameters here, to have the table for the 2 sets, for example, or the parameter she will use in her work. I hope she done that later. Okay, so run it, get the answers from here. These are the results. That's zooming using the lens as we done earlier. And these are the 3 points she will decide to discuss about. Okay, task number 3 is when we're going to have the block, and task number 4 we're going to have the roller. Well, I expect that she should get some results also here. She didn't do that. Okay, oh, she did that for the last one. She did for the roller, but she didn't do it for the pendulum, which is also can be extracted. Oh, sorry, she had the analysis. Why I always jump to the conclusion? Conclusion of the MATLAB handwritten calculations. Okay, she made a brief about the difference between both. I know she missed it. Okay, now she did the same thing for the virtual labs, and we're going to go through that step by step. Okay, and showing the results. That's what we task number 2 by changing the parameters. Experiment number 1, run the code, get the results. Experiment number 2, change the code, run the results, and then you can make a brief comparison between the 2 values. It's going to be nice, actually, if you would like to do the following. You're either going to take these 2 results from the first scenario compared with these 2, or you can find a way to export all the results as an Excel sheet. Then you can make your own graph, and you can make 2 or 3 graphs or 3 sets of the parameters on the same graph, and you can tell this is task number 1, this task number 2, or experiment 1, experiment 2. How to export the results to from MATLAB to an Excel sheet? A brief research on the Google will tell you that. Export. Okay, just follow the steps, put some extra lines and do that. Actually, if you do something like that, it's an extra work, you will, of course, deserve some extra marks for it. If it's going to be quite complicated, don't do it. It's not compulsory, but it's going to be a good advantage. Okay, so yep, and task number 3 is going to be for the tipping of the parts. So these are the task we are going to do: create the table of our log simulation data. Okay, that will be a nice thing, actually. I think they added themselves. Anyway, I will leave this one here for a while so you can make use of it. Okay, table almost like the Excel worksheet. Yep, these are the parameters for the different values. Okay, get the results from the MATLAB. Okay, the plots of the diagrams. Observe by zooming on the plot. The distance travel, the MATLAB values, our values, and the units has been also been done. Okay, and most of these code actually can be shown on the MATLAB when you run it. Okay, and then they're going to do the same thing with the Simulink to get the answers. Okay, and they're going to have a discussion between these results. I will leave this one, okay, because the time is already over. I just go through it, but that's very short. Who gave them a good mark for this one? Now that's actually nothing. So, for example, out of 10, I wouldn't give them more than 1 for this section. I know they run it, but they didn't do the work. There's no discussion, nothing at all, no introduction at all. Yep, anyway, I'm going to stop here. Please don't tell them that I said that about their report. And yeah, so these videos